So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is count partitions with even sum difference. So let us read the problem statement first. So you are given an integer array nums of length n. A partition is defined as an index I where I is between this range, splitting the array into two non-empty subarrays such that the left subarray contains indices from 0 to I and the right subarray contains indices from I plus 1 to n minus 1. In the end, we need to return the number of partitions where the difference between the sum of the left and the right subarray is even. So what is the question saying? Let us say you are given some array, something like this. There are some values in between. So you need to partition this array in such a way that the sum on the left and sum on the right, their difference. So sum of left, sum of right, their difference is an even number. So in total you need to return how many such partitions can be possible, whether we can partition it here, the total number of partitions that are possible. So we need to return that particular count. So let us see this first example, because this is an easy kind of question, so brute force approach will also work. So let us see this first example, which is 10, 10, 3, 7 and 6. So let me just erase this part. So yeah, the first example is 10, 10, 3, 7 and 6. So how many partitions can be done? So let us see. So first we will try out all the possible scenarios, because this is an easy kind of problem. So we can just brute force the approach. We can use the brute force approach. So yeah, the first possible partition is here. So the sum on left here is 10 and sum on right here will be this particular thing. So 10 plus 3 plus 20, 26. So here the sum is 26. So in this case the difference is minus 16, which is an even number. So we can keep a count answer, so we can make our answer to be 1 because this is a valid partition. So next partition we can do it here. So here the left value is what? The sum on the left is 20 and the sum on the right is 16. So here the difference will be of, let's say here will be 4. So 4 is again an even number, so we can just increment our answer count to be by 1. So currently our answer will be equal to 2. Then we can try out our partition here. So the sum on the left will be 10 plus 20, 23, and here it will be 13. So the current difference here in this partition will be nothing but of 10, which is again an even number. So we can again increment our answer by 1. So our answer will be now as 3. Then we can again partition it here. So this is 10, this is 20, 30. So left is here 30 and right is here is 6. So here the difference would be of what? 24, and 24 is again an even number, so we can increment our answer by 1. So our final answer will become 4. Why 4? Because we can partition at each and every index possible here. So yeah, the final answer is 4. So we can just check whether we have done the correct partitions or not. So yeah, our output is also 4, and these all are the valid partitions that they have made, similar to what we have seen. We have made partition here, here, here and here. Same they have done. So yeah, we can just try out the brute force approach and we can get the answer. So let us directly see the code now, how we'll be writing the code. So we are declaring an initial variable name as answer, which will be returning in the end, which will be the nothing but the partition count. So first we'll try out at each and every index. First we'll calculate the left sum. So this is nothing but the left sum, sum1. So for the left sum I am taking the variable as sum1. So we'll be keep on adding the numbers till 0 to ith index, because left is nothing but 0 to I and right is nothing but I plus 1 till n minus 1. So sum2 is the right sum, and yeah, we will be going from I plus 1 till n minus 1, and we'll keep on adding to our right sum, or sum 2 in this case. In the end, we'll just check whether the difference between the left sum and right sum is even or not. If it is even, we will increment our answer by 1. So we'll do answer plus plus. After doing this for each and every index, after trying out each and every index, we can just return whatever our total partition count is in the end. So yeah, this is how we'll be solving this problem. So I hope you learned from this video. Thank you for watching.